And now we'll hear from Mark Gray, Head of Strategic Partnerships from the Pawsey Supercomputing Research Centre. Thank you, Mark.
Thanks, Kerry. So my name's Mark Gray. I'm the Head of Strategic Partnerships at Pawsey Supercomputing Research Centre. And today I'm going to be talking to you. I'm going to mention our Trust and Identity project, but what I'm going to be talking to you today is about why we want to do this thing. So next slide, please. So Pawsey is, if you don't know, a Tier 1 Supercomputing Research Centre in Australia, one of two that are serving Australian researchers. We're located in Whadjuk Noongar land, the west coast of Australia, and we're here to provide supercomputing research facilities to the Australian research community. And we're very interested in making sure that that infrastructure can work well with for Australian researchers around Australia. So next slide, please. So you may be thinking, if we're running a big supercomputer, why do we care about getting it to work? Surely we run just one computer. It's one great big thing. People log on to it. What's the difficulty? The difficulty is that that is not, I think, the future of Australian research infrastructure. The Australian research infrastructure of the future is not going to exist as one mammoth computer that everybody comes to. In fact, I think there's a lot of evidence to suggest that the kind of complexity that Steve Manos talked about in his talk that researchers face when they come to using the computational infrastructure in Australia, in fact, globally, is not going to get less complex. It may in fact get more complex as we go forwards. And with our Trust and Identity project with the AEF, we're trying to figure out how does that actually work directly with the core computational infrastructure that provides our resource. How do researchers easily use our actual supercomputers with an identity system that will work. And an example of what this is going to look like is a project called the Square Kilometre Array that we are working with. The Square Kilometre Array, if you're not familiar with it, is a large radio telescope that's being built in the Midwest of Western Australia and also in Southern Africa. When complete, it will likely be the largest science project on Earth, and it will certainly be the largest radio telescope on Earth, probably the largest radio telescope you can build on Earth. And in order to support a project of that scale, a large computational infrastructure is being created to support both process the data and do the science. And what that looks like right now, as I understand it, is there's a core computational infrastructure that the Square Kilometre Array Observatory will be operating in Western Australia that will do the core processing of that data and then make it available to the regional centres around the world that will actually be part of the consortium doing the actual science with that data that's generated. And that data generated will be very large and require significant resources, both to process and store. In Australia, the SKA Regional Centre will be doing the core kind of science processing of that data, which is where scientists are getting access to that data, making it available to their collaborators. And then the Regional Centre and the SKAO were making that data available to a regional network of regional centres around the world in the partner countries that are part of the SKA. And they will be collectively making that computing data available to a very large number of researchers around the world. So what I'm describing here, of course, is a big distributed compute and data storage problem that will require a significant effort in terms of trust and identity to function. And you can imagine there's lots of different moving parts of that, individual, quite different compute infrastructures and storage infrastructures that are going to be created to form that system. Some of them will be running at Pawsey Supercomputing Research Centre. Some of them will be running at other infrastructures around the world. They need to all work together with a single kind of community and be easy to use for a bunch of researchers. And it's going to look a lot like the kind of bioinformatics workflow that Steve was showing in his previous talk. So if you go to the next slide, please. What does that look like in our region for researchers not doing SKA? Well, I think an example of that are current developments in Singapore. So NSCC, the National Supercomputing Centre in Singapore, recently announced the construction of a AI-focused supercomputer in Singapore, specifically just for the SingHealth system, and providing AI researchers to the whole AI infrastructure to the hospital research sector in Singapore, and actually running in their general hospital. I think that our future in Australia for computational infrastructure is going to look increasingly like this, where we're building domain-specific computational infrastructure, as well as the core computational infrastructure at places like Pawsey. These systems are all going to have to work together, and the nuts and bolts of that functionality is going to be deployed on the actual systems and have to work at a deeply integrated level with the compute to work. So next slide, please. So what does that look like in Australia? I think in Australia, what that looks like is large tier 1 supercomputing research facilities like Pawsey and NCI, where we're building large compute infrastructures that can provide high-level scaling for large computational simulations that have high-speed networking, integrated science support into those systems. And there are places where we're also investing research effort in new technologies that are going to advance the boundaries of Australian research infrastructure. But there's also this very, very important tier 2 compute infrastructure. And if I'll just put a plug in, there's a session at eResearch coming up next month, which will be actually discussing this exact topic, this tier 2 system, what it looks like. But I think it looks like the kind of infrastructure that's going to be built for the SKA, and it looks like the kind of infrastructure that NSCC is building in Singapore, where they're building domain-specific computational infrastructure to support specific requirements that may not be very easy to meet in the tier 1 infrastructure. And so these systems are going to have to work together, because it's the same pool of researchers that are using all this infrastructure, and they, just like in Steve's example, need to be able to move data and their identity between infrastructures without having to hit roadblocks every single time they're trying to do things. And so what we're doing with AEF and the Trust and Identity Project is trying to figure out how we get that working with our core compute so that that system can actually exist and be good for researchers and not make their lives too horrible. That's actually my talk, so thanks. The next slide. So thanks a lot for listening to me talk. I kept it short because I've really just got one topic, which is how do we make this work and why do we do it? I'll be around for questions later. Thanks very much. Back to you, Carrie.
Thank you, Mark. That was a great outline of how you see the future of trust and identity for national research infrastructure and the importance of seamless connection.